Testing? Hi, welcome to the video. Here's the problem we're looking at. It's an example from Quality Control. So we have some computer retail store, and they're concerned that the laptops that they're selling seem to need replacing more often than they would expect. So they did some research and found out that on average, laptops of this type have a lifespan of 4 years with a standard deviation of 0.6 years. So the owner of this store goes through and takes a random sample of 51 laptops he's sold and finds that the mean replacement time for that sample was 3.8 years. So someone who hasn't taken statistics could look at this 3.8 and say, well, that's really close to 4 years. There's probably nothing wrong with those laptops. Or they might say, well, it's less than 4 years, so definitely, he's getting, the laptops he's being sent must come from a factory that's not as good as the other factories, and so he's getting, laptops that aren't as good as the standard for this brand. So what he needs to figure out as a statistician is this 3.8 different enough from the expected time of 4 years that they think, yeah, their laptops really are inferior quality, or is it so close that it's just random chance that they just happen to get, a little bit on the low side? So what's the probability of seeing an average lifetime of 3.8 years if the true average is 4 years? So we'll go ahead and do that part of the problem, and then at the end we'll take a look at this piece. So let's go ahead and let's summarize our given information. For the population, the population is normally distributed. The mean replacement time was 4 years. Standard deviation was 0.6. That's for the population. Now we're looking at a sample of 51 laptops, so that's n equals 51. So for a sample of 51 laptops, the distribution of the sample mean is going to be normal with mean 4, standard deviation 0.6, divided by the square root of 51. So that's the distribution of the sample mean. Let's draw a sketch of that. So we'll draw a horizontal axis and then our beautiful bell-shaped normal curve above it, and keep in mind that bell-shaped curve is the 4, 0.6 over square root of 51. And just for reference, let's figure out what that is. 0.6 divided by the square root of 51 is 0.08. So the standard deviation is 0.084, saying that that's pretty small, right? We're expecting on average these laptops to last very close to 4 years, right? The standard deviation is just 0.8. If the standard deviation were like 2, right, then we'd say, okay, 4 years, but many of them will last, up to 6. Okay, so now we'll draw our picture. Here's our mean at 4. The value we're interested in, 3.8, that's actually more than 2 standard deviations below the mean, right? That's 0.2 below the mean, and the standard deviation is only 0.8. So this number 3.8 is pretty far out here. And we're wondering, what is this probability? What's the probability of getting a sample average that low or lower? So what is this area? So to calculate that area, whenever we have a normal curve, if we know a value of interest and we need the area, we can use the command normal CDF. And we're going to input, first of all, the left-hand boundary of the area of interest. This goes to negative infinity, so we enter it as negative 1 E9. And then the right-hand boundary would be 3.8. And then the mean is 4, and the standard deviation is that 0.6. divided by the square root of 51. I like to enter it in the calculator just that way as a fraction so I don't have to deal with rounding. So when I do that, I'm going to do second vars. Option 2 is normal CDF. And then we enter negative 1 E9, 3.8, 4, and then 0.6 divided by the square root of 51. And we come up with the answer 0.0086. Rounded to 4 decimal places. So that would be my probability here, 0.0086. So if we think about that as a percent, that's 0.8%, less than 1% chance. So even though 3.8 looks very close to 4, the chance that a sample of 51 laptops would have an average lifetime this much less than the mean lifetime is very small. It's a less than 1% chance that it would happen at random. So if we now scroll down to part 2 of the question, what does this manager conclude? Does he think that his computer store has been given laptops of lower than average quality, or does he think this just happened by chance? Well, the probability that it happened by chance, right? Probability it happened by chance, we could say, was that 0.0086. If we put it as a decimal, it's 0.86% chance of that happening at random. So we could say, does it appear the computer store has been given laptops of lower than average quality? Yes, definitely. It looks like they have, because the chances of getting a sample mean that far below the mean is less than 1%, which is less than that 5%. So we say it's unlikely that it was just a fluke that all these laptops lasted shorter than they're supposed to. Probably it happened because they're being shipped from a factory that has lower quality control standards, or I don't know, who knows why it's happening, but this is pretty good evidence that it is happening. He could take this back to the manufacturer and say, look, something's off here, you need to re-examine your supply process to me, or maybe I'm going to find a different vendor. Alright, I hope that was helpful.